Very good morning to one and all present over here. Uh, Dear authors and invited guests, welcome to Technical Session 3C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th International Conference on Smart Trends in Computing and Communications through Zoom. I hope you will all enjoy the knowledgeable and interactive sessions throughout the day. And if you have any query or any update, you can write it to me in the chat box. And there's one special note for the presenters that you have. Just a second. Yeah, that you have to wait for the end of the session so we can capture a good memories of this virtual conference. And in this session, we have 8 presentation, and each presentation will be given 8 minutes for the presentation and 2 minutes for the question and answers. And on the 7 minute, I will raise a gentle reminder to conclude your presentation. Okay. And just before we get started, I would like to invite our session chair to chair the session. Professor Paras Kothari. Professor Paras Kothari is presently working as a professor in the domain of computer application and pursuing research in information system implementation in various segments of business and medical sciences. Recently, Dr. Kothari is awarded academic recognition of honorary doctorate of engineering for his contribution in study in expert system and MIS in cognitive neuroscience. He's experienced more than 22 years of in academic and his career and with versatile research papers in national and international journals leads Dr. Kothari towards academic research. Presently, his 3 research theses are submitted and 3 are in progress with esteemed private universities of Rajasthan. Thank you, sir, your valuable presence over here, sir.
Thank you, Harsh. Thank you very much. Good morning to all. Please proceed.
Okay, so moving for our first presentation. Our first presenter is Priyanka Mishra, and she's presenting on a review on blockchain strategies and its applications. I think so. Priyanka is not here. Okay, so moving for our next.
We can move to the next, and when Priyanka will come back, we'll take presentation.
Okay, so next presenter is Vittal Badami, and he is presenting on a study on comparative analysis of machine learning and image processing techniques for identifying plant leaf disease. Dear presenter, you may please start your presentation.
Yes, very good morning, sir. Shall I share the screen, sir?
Yes, you can.
So I hope the screen is visible.
Yes, sir, it is.
A very good morning to all. So this is Vittal Badami from KL Technological University, Hubli. So today I'm here to present my research work on a study on comparative analysis of machine learning and image processing techniques for identifying the plant leaf disease. So let's move on to the agenda. This is the agenda for today's presentation. And coming to the introduction part, since agriculture sector is one of the major domain in India and many farmers are dependent on it, so we expect a good crop yield and to prevent the damages of the crop as minimum as possible. So the diseases that can affect the crop, which reduces the crop yield, are very much causing loss to the farmers. So the diseases should be identified and should be classified. So there are various methods in which we can identify the diseases. There are normal procedure, scientific calculations can be done by the agricultural scientists, and even farmers are well versed in identifying the diseases. But coming to the manual inspection of the diseases, it takes a lot of time and it is a very tedious task to do so. So that even now farmers are having a hands-on experience on the digitalization, even they are getting a good hands on the mobile smartphones. So a small step towards identifying the diseases digitally using deep neural networks have been tried here. So the deep neural networks are the basic neural networks blocks, artificial neural networks, which aim in providing automation for image classification and object detection and computer vision related techniques. So now let's move on to the motivation part. Coming to the motivation, so there are various machine learning techniques available, like we have regression analysis, SVM, and very traditional, conventional machine learning algorithms. But why to go with deep learning? So deep learning provides one of the good feature, that is automatic feature extraction, which is one of the major drawback in case of traditional machine learning algorithms, where we cannot see the automated feature extraction, where we have to write the manual extraction rules and the logic to extract the features when it comes to image classification. Since image classification and object detection could be easily carried out by deep neural networks, we prefer going with deep neural convolution neural networks. So the major drawbacks that we overcome with the deep learning methods are, it takes time to train the CNN model as well, and it is also not suitable for edge devices. Since because of the architecture is itself bulkier, it is not suitable for edge device implementation. Coming to the literature survey. So the literature survey is split into three parts: image classification, object detection, and severity quantification, which are in turn divided into sections based on algorithmic approach. So let's have a look into that. Coming to image classification. So when we surveyed image classification based methodologies for identifying the plant leaf disease, the authors were successfully able to classify the images into the disease category, which disease it belongs to. But there was a slight trade-off between accuracy and the dataset size. So what this one we have found out is that the dataset size, as the dataset size increases, there is a slight decline in the accuracy, and this happens because of the complexity of the architecture. Since the architecture complexity is very low, the dataset size matters a lot in the architecture wise. As we can see in case of the first author's paper, here we can see that there are 18,000 nearly images, and it has achieved an accuracy of 94.95% with a linear architecture. On the other hand, we have seen a data set with which is a very small data set of 241 images size, which have achieved an accuracy of 70%. 70 to 76%. And again, we also see further we have like 70,000 images which have been taken, and again we have seen a decline in the accuracy. So there is a general trend that when the dataset size increases, there should also be an increase in the complexity of the algorithm. That is one of the major potential gap that we have found out by surveying the image classification techniques. Next, moving on to the summary of image classification methods, we can have a comparative analysis of dataset size versus accuracy. This figure on the left-hand side represents the pie chart, which contains the dataset size. Here, you can observe that in the 9th paper, we have a 70,000 images dataset, and it has achieved a minimal accuracy. And on the other side, which has the paper one which has the highest accuracy, has a optimal dataset, that is with a narrow dataset which is not overfitting to the model to be trained. Coming to the object detection methods. In the object detection methods, we have surveyed different techniques which involves image transformations and color analysis, and based on localization of the diseases. Here also we have seen a general trade-off between accuracy and the methodology being approached. Since the dataset were not disclosed by these papers, we couldn't display them. So the constraints and the objects that what we observed is the poor pre-processing image pre-processing techniques. So since major object detection technologies, they have employed cost expensive techniques to identify the diseases. We'll see in the next few slides. Coming to severity quantification. So severity quantification is a method wherein we try to identify the intensity of the disease in a particular part of a plant. Hence, we are mainly restricted towards the leaf of the plant. The severity quantification is measured only in the leaf area. How fast the disease is spreading in the leaf is what we are trying to guess with the severity quantification. Here also we have seen color analysis, deep neural networks based, and also localization mechanisms. And another one methodology that what we come across in severity quantification is thresholding. Like in observation of color analysis, when the color changes from green to some other color, we show that it is an indication of a disease. So we set a threshold that above these pixel values, if there is a change in the color, then it is indicated as a disease. So such techniques can be observed in this figures shown here. So this is one of the papers being surveyed. The results are shown here, wherein we can see the leaves being displayed here. which contains a disease in this area, which is the color is quite changed between the background color of the leaf, and applying image segmentation technique, you are able to capture that diseased area, and by calculating the total area minus infected area, you are going to get the severity, in the sense the total area of the leaf that is being damaged. So here the authors have expressed the object detection, image classification, and severity quantification. All of the results are presented in a single algorithm. Whereas in the second figure, if we have to see, the image segmentation is being applied, wherein we are just able to see the change in the color, which is only a object detection. In object detection, we only identify whether the plant is healthy or diseased. In the third figure, we can see that there is a lot of equipments being arranged in order to identify the color change. It is just to monitor the color change, we need to have a huge setup. So this is how it is expensive in case of object detection. Coming to the dataset description. So for our research, we have collected 1,000 images from University of Agricultural Sciences, Dharwad, with the concerned experts. And we have collected the diseases for rust and late leaf spot, the images of which are shown here. This is the healthy leaf. This is the diseased leaf, which is called as a late leaf spot. The next stage of this late leaf spot is called as a rust, which is the advanced stage of the LLS. So we have to identify these portions using a computer vision or an image processing technique. So how do we do it? Coming to proposed methodology. So here we have a faster RCNN and object detection model. We need to localize this disease and try to identify the severity in the leaf disease. Coming to the object detection, here you can put a localization bonding to this to provide a notification that there is a presence of the disease here, and later we can train the model and obtain the object detection model and apply severity quantification. So this is the algorithm for severity quantification, wherein you are reading the RGB color value and applying a mask. Here basically we are trying to take the total area, green color, and masking off yellow and brown so that we get the affected area, brown and yellow. Then we are trying to calculate the infected percentage by taking the percentage of affected to the total. So this is how the severity quantification works. Coming to conclusions and discussion. So finally, through this research, we conclude that CNNs and deep neural networks are the preferred way for image classification and object detection. But however, not all the techniques that are suitable for identifying the diseases. In our scenario, the image classification using object detection and severity quantification holds good, but depending upon it also depends upon the diseases. If the disease is changing the color, it is only in terms of color, then we can apply color analysis, which could be very efficient manner. So this is how it can be implemented. Coming to the applications of the research work, this research can be very useful to the researcher working on disease detection and severity quantification. The same ideology can be applied to the similar kind of disease on the other plants as well. And it can also be used to develop an automation of a tool used to calculate PDI, that is progressive disease intensity, in a leaf or a plant, so that it becomes very useful for the agricultural scientist also to tabulate the disease progression. Thank you.
Thank you, Vittal.
Yes.
Harsh, do we have any question in your box?
No, sir. If you have, we can ask it.
Okay. I'm having one small query regarding
Yes.
your research paper, Vittal.
Yes.
Do you introduce any algorithm or process to measure the density or
Yes.
intensity of the disease on leaf?
Yes. Yeah, sir. Basically, coming to this algorithm, sir. Here, in the first part of the algorithm, here we are just identifying the disease area. So, intensity in the sense, what area of the leaf is exposed to the disease. So based on that, we have the research papers being published by the agricultural scientists. They have the theories related to that. They have formulas. Based on that, we need to correlate with our approach. That is what this algorithm.
Okay. So this, with the help of this algorithm, you are doing the comparative study based
Yes,
on
sir.
the other research papers published by the agriculture scientists.
Agricultural scientists, yes, sir. Because it is a collaborative project among agricultural scientists and we engineers. Because once we implement the thing, how effective is it? They only can give us an input.
Yeah, that's why, because when we know that the density or can say the effectiveness of the disease on
Yes.
the leaf, then only we can plan for further actions. How we either we need to protect them or we need to remove them, and
Yes.
that's all. And that is how we can help, or we can develop the applications for the save the plant and from diseases.
Yes, sir. Basically, yes, sir. Yes, sir. That's what we are into, sir. We are just starting the implementation phase. So this is what we are planning to do.
So thank you, very good, and all the best.
Yes. So thank you very much.
Thank you, Vital, for your great presentation.
Thank you, sir. Thank you.
Okay, moving for our next presenter. Our next presenter is Shonika Gaud Yeda, and she is presenting on caption suggestion through facial expression analysis.
Good afternoon, everyone. I'll be sharing my screen. Can you see my screen?
Yes, we can.
Okay. Good afternoon and good morning, everyone. I'm Sonika Gaud, and I'm from Vienna Vignana-Jyoti Institute of Engineering and Technology. Our project is about caption suggestions to facial expression analysis. The abstract. So here, our project involves usually people post pictures on Instagram, and they usually search for hours and hours for a good caption, and it wastes a lot of time. And our project aims to minimize the time they spend to search for a good caption. Instead, we help them choose a better caption through facial expression analysis. By detecting the emotion on our user's face, we suggest an emotion based on their emotion. For example, if they are happy, we suggest a happy caption, and if they're sad, we suggest a sad caption. So introduction, we are using convoluted neural networks for our project, and here we are having a already existing file of related captions for each emotion. And once we analyze the emotion on the user, we suggest different captions. The user can also randomize the captions as long as until he finds a caption that is suitable for his post. The existing system, there are many systems that have incorporated this caption suggestion through facial expression analysis, but the analysis part itself wasn't very accurate, and also it required the training data took a lot of time, and it wasn't very clean. Proposed system. Here we are proposing that we are caption generation through facial expression analysis model is much more accurate, and our captions are more relevant. So we have surveyed a lot of literatures like facial expression recognition by de-expression, residual learning, and a lot more. And we have realized that they aren't as accurate or relevant, or the system itself was very expensive. And yeah, the system architecture. Basically, here the user has to input image, and our system, it pre-processes the image, and after it generates the caption based on the expression that the user is portraying or displaying on his face. Algorithm. So first, collection of data set of images. Here we used for 2013 data set. Here the data set has already been classified into like angry, disgust, fear, happy, sad, surprise, and neutral sets, and it consists of 28,709 images. Some of the data is not very clean, but it is a good data set. Pre-processing of images. Here we clean the data set and check for any missing values. And then we augmented the data to fit our parameters, to the model parameters. Building the CNN model. We used convoluted neural networks, like I previously mentioned. Here we also used a softmax function to ensure the result comes in probability, and then based on that, we display whatever emotion the user is portraying. Training the model, we trained the model, and we used a batch size of 32 and epochs. We ran for 30 epochs. Saving the mod, and we saved the model, and we generated the caption based on the emotion. So this is an implementation. Here the test image is of a happy person, and the result we got was that the person is happy. And based on that, our caption is generated. This is a happy caption. All it takes for anyone to live a happier life is to live it one smile at a time. And this is our plots. This is accuracy with epochs. This is just, we ran it for 5 epochs because we didn't have enough time. And this is the loss with epochs. So these were the results. We got good results for happy, angry, and as well as sad, but surprise was a little bit of problem. We were usually not getting accurate results for surprise. And the future scope, we planned on actually even implementing using the background of the user. Based on that, we could have generated images, and then we also aim to improve the accuracy, because for 2013 wasn't a great data set, but we wanted to find a data set that could be more relevant and be built better. Thank you.
Yeah, thank you, Sonika. Do we have any question, Harsh, in the box?
No, sir. We don't have any question.
Okay. So again, there is one small query from my side, Sonika.
Yes, sir.
In your result analysis, when you got a surprise instead of sad, sad instead of surprise, so did
Yes,
you
sir.
find why this is happening with your algorithm?
Yes, sir. We checked the data set. We checked through that, and we found very irrelevant images. Like we found animated images or images that were very. They actually looked angry sometimes, or they looked surprised. So I think because of the unclean data set, we had a lot of issues.
So have you tried to make it on the on data set after cleaning, or can say adding some more relevant images for that?
We tried to find other data sets, but there weren't many, and some of them were expensive, or most of the data sets had the same issue. And we tried to remove a few of the emotions like surprise, and then we got a better result.
Okay. So suppose if I am using the emoticon related with the surprise, then also if the result is same, or it is having some different values?
With the emoticon, I think with the emoticon it shows properly, but the image it doesn't show that relevant.
Okay.
Yeah.
Okay, thank you.
Thank you.
Okay, so moving for our next presenter. Our next presenter is Smita Noel, and she's presenting on CFG analysis for detective vulnerabilities in smart contracts. Dear presenter, you may please start your presentation.
Yes, sir. Good morning, everyone. Is I audible?
Yes, ma'am, you are audible.
Okay. Good morning, everyone. I am presenting CFG analysis of detecting vulnerabilities of a smart contract. A smart contract are blockchain-based program that operate under certain conditions. And blockchain is a distributed database or a ledger available to all networks. So we mainly we are talking about today blockchain, and blockchain is used in many areas like supply chain, medical health, and everywhere. So the connecting nodes, which are the member of the blockchain, they are connected using the smart contract. And a smart contract is a program which is which is programmed using some languages like Solidity, Viper, Rust. Many more languages are there. So the smart contract enhances the speed, accuracy, efficiency, trust, and transparency. So a smart contract basically is the conditions that both the connecting nodes or the many nodes are member of the blockchain, all those conditions are written in form of language, in a programming language. So if both the nodes are satisfied, then they sign that contract, and that contract is deployed on the blockchain, and both the connecting nodes will satisfy those conditions. So if we take an example of supply chain here, when the sender send the package to the receiver and the receiver get the package, then the amount will be credited to the sender account. If this condition is satisfied, then all the credit goes to the sender account. So smart contract only work when the certain condition is met. So why we analyze the smart contract? Basically, we are talking that smart contract is written in programming language, and every programming language has some logical error, some syntax error. Due to these errors become the vulnerability, and vulnerabilities are the loopholes that attacker can easily take the benefit of vulnerabilities and get the all the ethers which are embedded in the smart contract. Ethers are the basically the money which is embedded in the smart contract and used on the Ethereum blockchain as a for any transaction. So, and if the vulnerability is there, then the contract will also use the excessive gas, and a smart contract used in many areas. So it should be a very big concern that a smart contract should be vulnerable free. And there are some challenges in smart contract that till now it is not very much used in everywhere, and there are very few developers which efficiently program the smart contract. So smart contract are difficult to change after deployment, and this is also the challenge in smart contract, that if the smart contract is deployed on the blockchain and it can never be changed. If anyone wants to some changes in the smart contract, then it should be designed again and then deployed again. And the loopholes due to indirect due to smart contract, we can eliminate the third party also. Smart contract high value transactions are also required. Vulnerability in smart contract can cause considerable losses, and smart contract are unchangeable. So vulnerabilities are the exposed to the possibility of being attacked or damaged either physically or emotionally is called vulnerability. We can learn lesson. So vulnerability achievements is that we can learn lesson and avoid some mistakes. And a number of possible solutions to the vulnerability are proposed, which make the smart contract more secure. There are some weakness also that we can get only the vulnerabilities which are already discovered. So if there is any new vulnerability, then it will be very difficult to find out that vulnerability. There are some attacks which are due to vulnerabilities, like in 26th April 2016, due to vulnerability denial of service, there is a loss of 1100 ethers, and in 17th June also, and in last December 2021, due to vulnerability unprotected ether withdrawal, $120 million are lost, and there are many more attacks are also there. These attacks are due to the cause of vulnerabilities. So vulnerability is the major concern in a smart contract. So we find that there are some literature survey. There is a tool called EtherSol and Asgard Defect Checker. We mainly focus on EtherSol tool, which analyze the source code, of the smart contract, and then convert that smart contract in bytecode, and then analyze using symbolic execution. But we find that there are some problems with these tools, and we analyze using some data set. We will further discuss about that data set. Source code is converted in bytecode, and then that bytecode is understood by Ethereum virtual machine. So Ethereum virtual machine is work on bytecode only. So every bytecode belongs to some opcode. Like M store is bytecode is 52, and SS store bytecode is 55. So this way this side we say that the source code converted in bytecode, and the starting part which is shown in yellow part, and then red part, and then black part. These are the three parts of the bytecode. And the first part is loader code, second is runtime code, and third is SWAM has code. So first is loader code. Execute wants to store the runtime code on the blockchain. So the yellow part bytecode is stored on the blockchain. Runtime code which is used for blockchain, and then runtime code which is used for storing on blockchain. And third is which is third part contain the some type of hashing we use, so that hash part is converted in bytecode, and that bytecode is embedded in the ending of this bytecode scenario. Every opcode contains some rules, like scope is used for function self-destruct. If we contain the self-destruct function in programming, then it will then it's denoted by stop, and revert also denoted by stop, invalid return stop likewise. And like unary operation is for not is zero, call data load. This way, binary operation are like add, multiply, subtraction, division, mode, S mode, exponential, this way. So these every operation is denoted by some opcodes, and these opcodes are generated by the bytecodes, which I've seen, which we seen in previous slide. So our approach is we take the smart contract, which is written in Solidity language, and then converted in bytecode, and then bytecode goes to bytecode converted in opcodes, and then we use the EtherSol tool and analyze the opcodes, and that EtherSol tool generate a context-free graph, control flow graph, and we have the entry point, exit point, some push jumps, orphan jumps, entry block, dispatch blocks, functions, flow, and there are some other scenario generated in that CFG graph.
Sorry
So
to
this is
interrupt you, ma'am, but you have last 1 minute.
yes, sir. So there is a source code. This is source code example, and then source code is converted in CFG graph, which contain the opcodes. And if the condition is true, then it will goes to the next block, and if false, then it will goes to the stop block. So we contain the data set. We take the data set from SWC registry smart contract. We take the smart contract from SWC registry, where contain the smart contract in fixed and unfixed manner. Both manner there are smart contract. We convert the smart contract in bytecode, and then analyze the bytecode using EtherSol tool. So we analyze that after analyzing the bug bytecode, and after fixing the bug, we analyze the bytecode, we get the same bytecode. So there is some problem with the EtherSol, and we analyze those problems, that due to fallback function entrance point has varied among Solidity compiler version, it is harder. So this give this problem, that same CFG for bug and bug free bytecode, and it is not compared with the other tools which is famous for smart contract analysis, which is OINet and Miane, etc. And bytecode can manipulate, then EtherSol graph also changes, but the source code is same. So this is also the problem with the EtherSol, and EtherSol building function produce some ambiguous results, and there are misses unconditional jumps. This miss the unconditional jumps also in EtherSol tool. So different vulnerability of different pattern, but each vulnerability have can be written in other language also. But it is also EtherSol also failed to detect these vulnerabilities, and so we will further analyze these vulnerabilities using SMT and Z3 solver, which improve the CFG accuracy. So we will use SMT solver to improve the loops and conditions. It will remove the EtherSol bugs. Thank you. I'm expecting your valuable questions.
Thank you, Madam Smita. So, any question, Harsh?
No, sir. There's no question from audience.
Okay. Smita ji,
Yes, sir.
the things which were the limitations of EtherSol tool
Yes,
Have
sir.
you checked those data with some other tool like SGuard or something?
Yes, sir. Yes, sir. Yes, sir. We have checked those tools, but EtherSol basically used for there is a vulnerability. It's called re-entrancy vulnerability. EtherSol work for only this that vulnerability. So we take the data of that vulnerability only, and we check with other other tools also like ONET, Miane, SGuard, other also.
And did you find some points
Like,
where we can say that it is working better on those ground than the
yes, sir.
EtherSol?
We find that in some cases, like if the smart contract has some vulnerability, then it is failed to detect using EtherSol, and we can easily find using ONET also.
So did you include those data in your research, or you have put those for the future?
Yes, sir. Yes, sir. We will analyze in future work on
Those things. Okay, you will analyze those with the same smart contract. Right?
Yes, sir. Yes, sir.
Okay. So thank you, Mr. Pita, and
Thank you, sir.
good luck.
Thank you, sir.
Thank you, ma'am, for your great presentation.
Thank you, sir.
Now I'd like to invite our next presenter, Iti Koshi, and she is presenting on image forgery detection using deep learning. Dear presenter, you may please start your presentation.
Okay, sir. So can you hear me?
Yes.
So good morning all. I'm Niti Koshi, going to present the paper Image Forgery Detection using Deep Learning. So as an introduction, capturing images has been increasingly popular in various recent years. So the variety of tools are available to improve the image quality, and they are also frequently used to falsify the images, resulting in the spread of misinformation. So this increases the frequency of image forgeries, which is now a major source of concern. So numerous techniques have been developed over time to detect image forgeries. So the main problem statement with this research work is to detect the forgery of images using deep learning techniques. And the related work with the forgery is most of the forgery detection techniques are related with copy move forgery or either image slicing or image resampling. Here there is one work that is Mandra network can work with both copy move forgery and also image slicing. And Busternet is another network that is basically for copy move forgery alone, and CatNet is a network that is doing only with the slicing of image forgery. So the proposed system concentrates both for detecting image slicing and copy move forgeries using deep learning technique. So compared with the other existing techniques, the proposed system can detect fastly image forgery in less time. So in recent years, convolution networks have received much attention in image slicing and also copy move forgery. So image slicing means it's a copying a part of the image and pasting it to another part of the image, creating a different image. And copy move means copying a portion of the image in the same picture or image, creating a forged image. So proposed is a CNN-based network with the goal of learning and accurately detecting forgeries in the image in an image. So these are the samples that is showing copy move forgery as well as image slicing. We have two images putting together to create a new image, new fake image. So the next is the copy move forgery that we have copy. The first we have an image copying a part of the image to another portion of the same image, creating a forged image. So the data set that is used for this study is CASIA 2.0. Here that data set contains 12,614 images and 7,491 are the genuine images and the rest 25,123 are the tampered images. And this data set consists of various categories like animals, architectures, plants, natures, etc. And the resolution of the image varies from 800 to 600 pixels, and also it includes 384 into 256 pixels. So these are the images that is present in the data set. So the proposed architecture receives an input image and convert the image into an RBG image as the pre-processing step. And the pre-processing steps consist of two processes. One is the conversion of the RBG and is to convert to ELA image. And third, ELA image is then used for the training process. And the training process, we have the convolution neural network, which consists of 3 convolution networks and one fully connected network, which receives an input image of 128 into 128. And this we create a model, and using that model we can trace the image and check whether that image is real or forged. And these are the pre-processing steps. What is the normalization in order to enhance the performance and reliability of the machine learning process. And this is the result obtained, which creates a NumPy array. And also in addition to this pre-processing and conversion of RGB, we have also doing a flattening process in order to reduce the amount of.
Ma'am, sorry to interrupt you, but your slide is not moving.
Okay. So
You're on the first slide.
can I stop and share again?
Yes, ma'am. Please.
Can you see it, sir, now?
Yes, ma'am. It's a flattening slide, like, right?
Yeah.
Okay,
Can I show
yeah.
it from the beginning?
No, ma'am. It's okay. You can start it from there.
So this is the architecture, pre-processing, flattening, and next is the ELA image. So identifying areas in an image with different ELA process is used to identify the areas in an image with different compression level. There are different types of compression: is media compression, mild compression, moderate compression, and firm compression. And this process is used to detect similar images and that have similar brightness and similar process of converting an image, RBG image, to a similar or edges to similar texture with the same format of the image. So this is the pre-processed data set after the ELA process. So the model can have 3 convolution layers, two average poolings, then 2 dense layers, and 2 batch normalization and a flattening process. And this is the accuracy of the model that we created. As accuracy we got is 0.89%, and the validation accuracy of 0.913%. And this is showing the accuracy versus a number of approx. As the graph shows, during the training process, accuracy increases to 0.85%, and the loss is very much reducing. So this is the UI design we have created for the testing the image. As a conclusion, the proposed technique can effectively detect image slicing as well as copy move type of image forgeries, resulting in an overall accuracy of 91.35% with a limited defined iteration limit. These are the references we have gone through. Thank you.
Thank you, Ms. Leti. Do we have any questions?
Thanks.
No, sir. There's no question from audience.
So this time from my side also there is no query. So
Okay.
Good luck. Thank you.
Thanks.
Okay. Thank you, Leti, for your nice presentation. Okay, so moving for the next presenter, Kanchan Chavan, and she's presenting on jitter measurement system with PS resolution for calibration of nuclear timing spectroscopy system.
Sir, am I audible?
Yes, ma'am, you are audible. You can
Okay.
present your
Yes,
paper.
I'm sharing my presentation.
Yes.
Can you see the screen?
Yes, ma'am, we can see and make it full screen. So,
Good morning, everyone. Myself, Kanchan Chavan. I am faculty and research scholar from Vivekananda Engineering College, Mumbai. And my research area is developing hardware, nuclear electronics for nuclear instrumentation domain. So today I will be presenting my research paper on jitter measurement system with picosecond resolution for calibration of nuclear timing spectroscopy system. So today's paper presentation, given the short time, I will be quickly explaining the conventional nuclear timing spectroscopy system. So basically a conventional nuclear timing spectroscopy system, as you can observe here, that the radioactive source emits the radiation which reaches to detector. Detector provides the analog output pulse corresponding to the incident radiation energy. This pulse is provided to time peak of circuit, which provides digital signal, which is time correlated with the detector output signal. Time peak of circuit output two signals, start and stop pulses, are given to time to amplitude converter, which gives analog output voltage corresponding to the time interval between start and stop pulses. This analog voltage is further digitized by making use of ADC, which is internally present inside MCA. So in the conventional timing spectroscopy system, for the proper operation of TAC, stop pulse is always delayed after start pulse by using fixed delay, and this fixed delay introduces offset in the ADC output voltage. So for which bias amplifier is required to remove the DC offset and to get better resolution with the existing number of channels of the MCA. So the conventional nuclear timing spectroscopy system has jitter in the output because the detector output pulse varies in pulse shape as well as rise time for the same incident radiation energy. Time peak of circuit output shows time walk of the signal. Delay which is introduced, it is of the order of nanosecond, which shows picosecond jitter in the output. So to validate the existing conventional timing spectroscopy system, we propose a hardware which is called as jitter measurement system. So the start and stop pulses from the time peak of circuit will be connected to the conventional timing spectroscopy system as well as to our hardware jitter measurement system. The digital code from the conventional system is used to develop a spectrum, and the jitter measurement system output digital code is also obtained, and the spectrum is developed, which is called as timing spectrum. So various analysis in nuclear domain is done using this timing spectrum, and which is a very important exercise. So in the jitter measurement system, after the performance evaluation of the system, we have observed that the spectrum spread full width at half maximum, it is of the picosecond level, and the conventional nuclear timing spectroscopy system, it is showing a nanosecond spread. So if we subtract the spectrum of jitter measurement system from the conventional timing spectroscopy spectrum, we can calculate the jitter in the existing conventional system. So this is how the total jitter present in the system can be calculated using our hardware. So the system can be used for validation and performance evaluation of the conventional system, as well as individual block jitter measurement is also possible with our system. So for example, if time peak of circuit is showing a jitter, that can be also evaluated using our jitter measurement system. So the jitter measurement system consists of integrated timing spectroscopy system. So the dotted bracket here, the components inside dotted bracket here shows an integrated timing spectroscopy system, which consists of free running RAM generation circuit, the output of which is connected to two tracking ADCs. The ADCs selected for the implementation of the system are SAR ADCs with 16-bit resolution with very good acquisition jitter and acquisition sampling time. The two ADCs code is obtained using microcontroller, and the difference in the two ADCs code is calculated to measure the time interval. The system is designed such that the reference voltage given to the free running RAM circuit and ADC is maintained the same. So it is observed that the free running RAM circuit and ADCs are tracking the temperature effect in the similar manner. So in the conventional system, there are various, this is the actual system, and we see a lot of wires which are not hardwired in the PCB design, because for our testing, we have to make certain changes external to the PCB. So the integrated timing spectroscopy system offers a lot of advantages compared to the conventional system. The dead time of the system is 1 micro, which is very less compared to the conventional system. Linearization techniques are not required. Range and resolution of the system can be very easily adjusted, and spectrum stabilization techniques are not required. So when we carried out the performance testing of this jitter measurement system with different experiments, in the first experiment, we have generated a very narrow RAM of 600 nanosecond duration, And it can be seen that it is a very good linear RAM of good quality. And with 16-bit ADC, the resolution obtained with our system is 600 nano divided by 2 power 16, which is 10 picosecond approximately. In the second experiment, we have evaluated the total performance of the system, where the linearity of the system is tested. So comparator is used to generate the start and stop pulses. The comparator output can be connected to programmable delay generator ICs, which can give a delta T time interval increment of the order of 1 nanosecond. So in the first experiment, the comparator start-stop pulses are generated on the beginning portion of the RAM. And the graph here shows the points 1, 2, 3, 4, 5. This is an ongoing continuous experiment. So to develop the point 1, we have taken ADC 1000 readings, ADC 2000 readings. We have computed the average, and the offset between the two ADCs code is plotted on the y-axis. So in one experiment, we have varied the PDG code to have a 100 nanosecond step size in the time interval. And in the second experiment, we have taken a very short step size of 5 nanoseconds. So in both the experiments, the total jitter measurement system had shown a very linear performance. In the third important experiment, where the spectrum is getting seen, what we have done is comparator output, start and stop pulses, which are occurring at the same time instant, is given to jitter measurement system. So ideally, the jitter measurement system code output difference should be 0. But because of certain component limitation, we will get a spectrum spread. So looking at this spectrum, LabVIEW software is used to develop this spectrum, which is called as nuclear timing domain spectrum. And the full width at half maximum is getting seen to be 2 to 3 counts. So with this, it is observed.
Sorry to interrupt you, ma'am, but you have last
yes,
1
sir.
minute.
I will conclude in half a minute. So the existing system with 16-bit ADC can be further upgraded with 18-bit ADC. So this is analog devices AD7960. So with 100 nanosecond RAM and 18-bit ADC, typically 0.38 picosecond resolution can be obtained. This ADC also offers 200 nanosecond conversion time, and aperture jitter, which is important parameter for our system, is of the order of 1 picosecond. These are certain performances of the 18-bit ADC, which shows that the 18-bit ADC has shown a very less code spread at the output. So we conclude that the existing 16-bit ADC jitter measurement system can be used for picosecond jitter measurement for conventional system. And with narrow ramp of 100 nanosecond and 18-bit ADC, the system can be also used for FPGA-based ADCs, which are having picosecond level jitter measurement. These are few references. Thank you.
Thank you, Mr. Kanchan. Harsh, do we have any question?
No, sir, we don't have any question.
Okay. Ms. Kanchan, I have only one doubt. Can you focus some of the applications of this integrated timing spectroscopy along with this?
Yes, sir. Yes, sir. For example, this system is required in defense in LiDAR devices for distance measurement, where laser source is used and it is reflected back from the object. So time interval has to be measured. Another application is speed measurement using non-contact technique. Some of the nuclear domain timing spectroscopy experiments require this setup, which are very costly in the commercial domain.
Okay. Is it your PhD or research topic?
Yes, sir. Yes, sir. I'm concluding with this paper my PhD work. And my guide is from Baba Atomic Research Center, who has worked into this domain for 30 years.
Oh, great. So he's a scientist in Bark.
He got retired and then he joined our college and he guided us.
Okay, that's great. Okay, thank you. All the best.
Thank you, sir, for your questions, and thank you, SMARTCOM.
Okay. Thank you, Kanchan, for your great presentation. Okay, so moving for our next presenter. Our next presenter is Aman Kumar Saini, and he is presenting on production scheduling on multiple parallel machines using recent meta-heuristic techniques. Dear presenter, you may please start your presentation.
Okay, thank you. Is my screen visible?
Yeah, yes, it is.
Okay, good morning, everyone. My name is Aman Saini. Today, I'm going to present this paper titled Production Scheduling on Multiple Parallel Machines using recent materialistic techniques, which is co-authored by Rema Komadat and Professor Prakash Kotecha. This is an outline of the presentation. So in this work, we have taken 5 materialistic algorithms, 2 of which are the recent winner of CC 2021 conference. CC stands for
I would like to suggest that you just start the presentation.
Sorry?
You just start the presentation by pressing F5. This is only the application on which you are showing the slide.
Yes, sir, you have to make it full screen.
Okay, the presentation did not start.
Yes, ma'am. Yes, sir.
All right, I did the full screen. Let me do it again. Is it visible now?
No, sir, it's still it's in slide showing.
All right, let me reshare.
Yes.
I think you have to share the presentation screen, not this application screen.
All right. Is it visible now on a full screen?
Yes, it is.
Yeah, now it is. Please.
Okay. Sorry for the inconvenience. So this is an outline of the presentation. In this work, we have taken 5 materialistic algorithms, 2 of which are the recent winner of CC 2021 conference. CC stands for Congress of Evolutionary Computation. It's a very prestigious conference which is held annually, where people submit their optimization algorithms, which are further tested on some hypothetical mathematical functions. The other 3 algorithms are also previous winners of CEC conferences, and these are very widely used and popular algorithms. So we have taken these 5 algorithms and applied them on a real life optimization problem, which is known as job shop scheduling problem. So we know their efficiency on hypothetical mathematical functions because that's where these algorithms are coming from. But we don't know their efficiency on real life optimization problems. So this is what we are trying to see in this work. We have also modified the structure of one of the algorithms, which resulted in better performance. So this is a brief introduction of all the algorithms. As you will see, as the year of publication increases, the complexity of the algorithms are also increasing, which you can see by looking at the user-defined parameters. Previously, there were only 2 or 1 parameters. Now we have 6 or 7 parameters in algorithms. Also, these algorithms are motivated by the behavior of by behavior of organisms in nature. Also, there are few techniques which were not used in older algorithms, like population size reduction. These are now new techniques which are used in newer algorithms. So this is the modification that we have done to one of the algorithms. We have modified the bounding strategy of this optimization algorithm. Previously, you would see if the decision variable goes out of bound, after applying the bounding strategy, the decision variable would still be out of bound and not inside the bound. But the new bounding strategy that we are applying, it's very intuitive, and it is known as corner bounding strategy. So anytime the decision variable goes out of bound, we are just pulling it back inside the bound with the nearest bounding limit value. So it's a more strict way of pulling back the decision variable inside the bounds. So this is an introduction of the problem. In this problem, we have a set of independent orders and a set of dissimilar machines. There are also few constraints. A machine can process only 1 order at a time. A single order cannot be processed using multiple machines. Each order should start processing after its release date and should be processed before its expiry date. The objective in this problem is to minimize the processing cost. Also, corresponding to each order and machine pair, we have processing cost and processing time. So these are the constraints that we just talked about converted into their mathematical form. Due date is each order should be processed before its expiry date. So if it goes out of its expiry date, we are just putting a penalty on it. Overlapping of order is that each machine can process only 1 order at a time. There should not be any overlap of orders. So if there's any overlap, we are putting a penalty on that. Maximum processing time. So no machine can work 24/7. So we are assigning a certain amount of time, a certain amount of processing time to each machine. And if the total processing time of all the orders on a particular machine goes out of this maximum time that we are giving, we are putting a penalty on that too. So this is the formulation of the problem. We are trying to find an optimal scheduling plan that minimizes the total processing cost. Total processing cost is simply the sum of all the processing cost of all the orders assigned at their particular machines. Penalty is the sum of all the penalties coming from different constraints. So objective function is simply total processing cost if there's no penalty. If there's a penalty, we are just adding that penalty to the processing cost. Also, the maximum processing cost we are adding at an extra term. This will help all the algorithm to converge to the optimal solution much faster. So this is the performance of all the algorithms on this problem. Here we are looking at 10 different charts because we have 10 different data sets of this problem. This will give us a more extensive view of performance of these algorithms. One thing that's clear from these charts is that the middle algorithm, the middle bar chart, that is the tallest in almost all the charts. So we can say that the middle algorithm DNL-PSO is performing worse because we want smaller bar charts. We want minimized processing cost. So DNL-PSO, the middle algorithm, is performing worse than other algorithms. So that's one thing from this chart. So this is the improvement in the algorithm we just modified. BS stand for bounding strategy. As you will look at the values, either the new modified algorithm is performing same or better than the original algorithm, as the values are either equal or lower than the original algorithm. So this is the conclusion. In this work, we have taken two CEC winning algorithms, which were not previously tested on any real-life optimization problem. We have also taken three older winners of CEC conferences, which are now widely used in different applications. We have taken all these 5 algorithms and applied them on a real-life optimization problem. We also modified the bounding strategy of one of the algorithms, which showed a very significant increase in the performance of that algorithm. DNL-PSO, one of the algorithm, performed relatively poorly in all the problems. There's no single winner in this problem, in this work, but we can say that these 3 algorithms, modified MATDE, IPJSK mode, and TLBO, provided very decent results. And this is an appendix. So those 10 data sets that you were looking at, they are coming from different combinations of number of orders and number of machines. If you look at the left side table. So as we are going down the data set, the complexity of the problem is increasing because the number of orders and the number of machines are increasing, and consecutively the number of decision variables are also increasing. On the right side, you are looking at the different parameter setting that we have applied to all the algorithms. So most of these parameter setting are inspired by from their original research paper of these algorithms, which are suggested by the authors. Thank you.
Thank you, Mr. Aman. Yes, sir. Do we have?
No, sir. There is still no question. Audience.
That's great. So basically, I just, Aman, will you put me on the last slide? Yes, this is okay.
Yes.
In these parameters, suppose that, have you ever changed any of the values? Because these are some standard values which are prescribed in their research papers and you have taken as it is.
Yes, sir. These are the values suggested in their research paper.
Yes. So did you try to change those values and finding some of the variation in that? This results means?
No, sir. Actually, we did not experimented with these values because most of these values are pre-adjusted. We give them an initial value, but these values change as the algorithm progresses. So most of these algorithms, they do an auto adjustment of these values.
Okay. So, but you had the monitoring on that, right?
Yes.
Okay. Thank you, Aman. Thank you.
Thank you so much.
Thank you, Aman, for your nice presentation. So moving for next presenter, Ashwin Srinivasa Ramanujan, and he's presenting on RTTSLC, a framework for real-time two-handed sign language translation.
Hello everyone. Am I audible?
Yes, sir, you are audible.
Yeah. Is my screen visible?
Yes, sir, it is visible.
Very good morning to everyone present. My name is Ashwin SR. Our article ID is 198. I'll be presenting our paper, RTTS-LC, a framework for real-time two-handed sign language translation. My co-authors are Mrs. Bharti R, Apta BV, Ankit BV, and Aryan Sharma. So Indian Sign Language, or ISL, is a very prevalent sign language used in South Asia, and it faces various problems as it is a two-handed sign language as opposed to single-handed sign languages like American Sign Language. The research on two-handed sign languages is very limited, and this motivated us to add to this field of research. We have come up with a framework for the translation of such two-handed sign languages, with Indian Sign Language being our research focus. So we propose, with our research, we propose RTTS-LC, real-time two-handed sign language classification. It is a novel framework for capturing sign language input. With our framework, we aim to address the research gap present in two-handed sign languages by drawing a single bounding box around the entire sign, as opposed to drawing a bounding box over each hand involved in the sign language gesture. We validated the image capturing framework with deep learning models. AlexNet, EfficientNet B0, and BGG16 were used to translate the letters of the English alphabet signed in Indian Sign Language. The results we obtained show that our framework is effective and can be used to help the hard of hearing community. From our literature review, we found that there were very less practical implementations of sign language translation systems. That the precision of two-handed sign languages was a lot lesser than single-handed sign languages in translation, and that translation is affected by factors like lighting, background, etc. It is inferred that there isn't a lot of work that incorporates real-time two-handed sign language classification. So our framework involves taking the input, pre-processing it, feeding it to a classification network, and obtaining the translated output. The first step is taking in the input. The real-time input, which would be a sign language gesture, is taken in through a web camera. The second step is the image detection. The image detection is done using an object detection model. In our research, we used MediaPipe, and the hands in the image input are detected. So the third step is to create the bounding box. The existing hand landmark model in MediaPipe was modified to adjust the entire sign by detecting the number of hands used. For example, A uses both hands, whereas O uses one hand. So the number of hands used is detected, and the bounding box is drawn over the entire sign. The next step is to crop the ISL gesture. The images are cropped to only contain the gesture in the end. The last step in pre-processing includes flipping the images and resizing them as needed for the classification model, as needed as an input for the classification model. So for the classification, we used AlexNet, EfficientNet B0, and BGG16. The output was the gestures classified to their corresponding letters, which are combined to form words. So BGG16 is a 16-layer deep CNN. It has about 138 million parameters. AlexNet is the smallest of the three used. It has 13 layers and 60 million parameters. EfficientNet B0 it helps with model scaling and in a conventional CNN. B0 is one variant of 7 variants, where B0 has 237 layers and B7 has 813 layers. For dataset creation, we created our own dataset. It contains about 26,000 samples with 1,000 samples for each letter of the English alphabet. For different users with different backgrounds, different orientation, different hand sizes were involved in making the dataset. And so the results we obtained was evaluated with metrics like latency, accuracy, and error rate. And we also used Matthews coefficient, correlation coefficient, or MCC. The MCC gives a correlation between true and false values. So it incorporates all the values and gives an output. So we found out that EfficientNet had very high accuracy with 99.6 and really good, less latency latency latency, whereas BGG16 gave us a lot of latency with 325 milliseconds, and AlexNet gave us a 60 millisecond latency. AlexNet had a comparatively lesser accuracy with 86.5, whereas BGG16 gave us 92.6. But then in the error rate, we got 0.074 for BGG16, 0.003 for EfficientNet, and AlexNet gave us a 0.1 error rate. The MCC showed that the MCC score for EfficientNet was 0.4. This was indicative that the model might have overfitted, and it was pretty high for BGG16 and AlexNet with 0.99 and 0.96 respectively. Our conclusion is that BGG16 had the best overall results. So in conclusion, our proposed framework is fully capable of accurately capturing gestures of two-handed sign languages and translating them in real time. With our framework, we address the cropping of the two-handed gestures in the same bounding box using object detection models and also the background noise. We believe that our framework will cater to the communication needs of people who are hard of hearing. Thank you.
Okay, thank you, Ashwin. That was a nice presentation indeed. And can you focus some of the applications of this? As you said that it's good for the people who are hard hearing.
Yes, sir. So in India, there are about 15 million sign language users, but then there aren't enough interpreters that can bridge the gap of communication between those who use sign language and those who don't. So this can be incorporated in a proper sign language translation system, this framework, and it would like help as a communication mode between people who use sign language and people who don't.
So as you mentioned in the introduction part, that the Americans are on the single written language, while we are the 200 sign languages. So
Right.
wanted to find what are the real difficulties that the two-hand sign language over the single-handed.
Okay, so Indian Sign Language or even Chinese Sign Language use two hands. So the existing image detection models, they draw bounding, they take in both the hands separately. So if we were to check the signs of B, O, and Q, so B and O have similarities in the right hand, and B and Q have the similarities in the left hand. So it would be it would give the same result for both signs. So these are some of the, this was one of the, how do I say, limitation of two-handed sign languages.
Yeah, very true. So thank you, Ashwin. Thank you very much. It was the nice presentation.
Thank you, sir.
All the best. Good luck.
Thank you, sir.
Okay. Thank you, Ashwin, for your nice presentation.
Thank
So
you, sir.
moving for our next presenter. Next presenter is Priyanka Mishra, and she is presenting on a review on blockchain strategies and its applications. Dear presenter, you may please start your presentation.
Sure, sir, sure. I'm too.
Yeah. Okay. So Priyanka is the number one, right?
Yes, sir.
Okay. Yes. Please proceed.
Good morning, Dignity.
morning.
My topic is like my review on blockchain strategies and applications, and right now I'm pursuing PhD in Vellore Institute of Technology, Chennai campus. So these are for contains introduction to blockchain technology approaches. Technical aspect of blockchain technology will cover up the features, issues and challenges, strategies, types of blockchain, different blockchain applications, conclusion, references. So normally, blockchain is introduced in 2008 by the Satoshi Nakamoto, and it be dominated kind of any phrases of bitcoins. First of all, it is a digital currency and consideration of the first observed by kind of any computerized monetary, where the kind of any individuals can use for their for explore new things related to any significant benefits. So mostly, what is the blocks? Blocks is a kind of digital records and transaction that from primary all the set of the blockchain, and it kind of verified by the and cryptography. It is a kind of cryptographic signature to themselves to chain themselves to next block, and that is a kind of it's a linear order to copy the last exchange since the past blocks of the chain, and the way of the block creates the chain. It is a kind of all the participants or users who can without help or with a third party validate transactions and can be used for their computers. So for the secure the data, we can elimination the centralized system and direct transactions we can do for the directly and intermediary services. And the blockchain is kind of updated by the agreement between the members in a particular framework and exchange. We can use the data and never be adjusted and immutable. So it's a circulated database. It can be hacked also. It can be distributed as a similarly customary, and the whatever the data inside the blockchain, it can be impossible to alter or it can be impossible to change. So whatever the issues yes, sorry, approaches is mostly it is like a trustless environment, and avoiding the particular middle of the person, remove the central control of the blockchain. It can helps to remove secure the transparent technology, and we can share the data through the kind of node to node network. In 2013 the Ethereum blockchain was it discovered, and the Ethereum it is on only cryptographic money, and it can create the application blockchain channels over the decentralized application. Again, 2015, it has come the Ethereum made another programming worldview by a decentralized app idea by presently smart contracts, making the first distributed processing model and working on the top of the blockchain channel. And it can be complicated component to duplicate shared, and it can be synchronized process information. So it can be spread across the various topological areas. For example, kind of any location or any locations of our country, any nation or any kind of organization or any institute. So mostly primary property of the blockchain innovation is absence of the central administrator, and a blockchain can be contain records exchange of the requester chain of informations, and it can be give the agreement of the any fake transactions, to example avoiding the double spending on the particular assets. So it can be never modified by the any user or deleted with an exchange of the any kind of properties. So most of the issues resolved by the approaches like in traditional way and a blockchain, there's a difference. We can see that traditional and blockchain. In traditional way, we can see that with single point attack, we more prone to attacking, and with blockchain, it is a decentralized network. So it is very hard to be attacked for the users. So in traditional way, central administrator can have full over the control, particularly the database and all that. In blockchain, this can be corruption in the system will be reduced and use as because it is can't be changed the blocks at all. If we can, if will be change one block, it will very impossible to change the another block, because it will be affected to the another block. So user can run on the network. So in traditional way, there is a kind of absence of transparency. There is no transparency, there no immutability. So admin can control the user access also, but in blockchain, there is a full transparency is there. So general public has full access on the blockchain. So in traditional ways, it is inclined to data tampering, as is unclinedly for the anyone to check for the same. But in blockchain, the data cannot be manipulated or tampered by anyone. So this is the technical aspects of the particular blockchain. So it is a like peer of the protocols, and the index 0, we can see the first one is hash of the block. So index 0, it can be hash of the previous block they were showing, hash algorithm, public key cryptography, and it is a consensus algorithm. So a blockchain can be comprised of a few thousands of companies, and the many companies are using now blockchain technology because it's a node-to-node network organize a particular structure. So at a flat topology with chain of the command, it can be chain of the central administrator and a primary server where can be shared the compatible ownership. So mostly P2P systems can be keep the blockchain organized in a proper manner, and a particular node and principal task is to approve the exchanges and procedure on the information we can, whatever state is stored on the exchange, whatever the information we are exchanging between the two users or receivers, something. So while we are saving the all information consistency, so mostly the blockchain gives the proper transparency to or guarantee to approve all the clients can refresh the information and on the blockchain. So it is kind of in blockchain, the nodes are interlinked called ledgers, and the nodes are also referred to the miners and producer. So particular nodes can be collect a set of the authorized and transactions in the particular block, which can link to other previous blocks and next to be blocks by remove the hash values kind of earlier and calculate the value of the new chain appending with the same. So normally, what is the hash value? So hash value is a unique advanced mark of digital kind of a fingerprint, cannot be example for content also, can be number also, can be report also, can be information data sets also. So it can be blockchain utilize the particular consensus algorithm calculation for the decide to legitimate a block, we can be could make it. For example, numerous blockchain also can have the principal inner that computes or that numeric value or block with a specific cryptographic properties. It can be other blocks are described in the particular. So features are called decentralization. Decentralization, what is the decentralization called? So decentralization is mostly a more fundamental component of the blockchain-based framework, which implies that in the blockchain-based kind of framework, the no longer relies on the central processing nodes. So which can understand the dispersed account and stock update the information. So kind of particular to understand the blockchain, we have to understand from both of the like technical perspectives. So blockchain system records and transact the value in peer-to-peer fashion itself. So it means there is a no need of trusted immediately such of like kind of banks also, brokers or other services as a trusted third party. So what is immutability? Data can't be changed after the verified appended on the blockchain. For instance, if we can give the example of Bitcoins. So it is a Bitcoin, the blockchain framework, X of the, it can nodes, it can control the framework, can be the same time control. Overall, 51% of the nodes, it can be controlled and the modification can be invalid. So transparency, the transparency is very reason of the trusted of the, because of transparency, the information of the records or database are updated and transparent to the nodes of the whole system. Consequently, nodes are very high transparency can be utilized to audit. Proof of the work. The proof of the work can frame two parties can be exchanged with the like grounds that be program health. So it's a kind of proof to exercise between the nodes and legitimate. So blockchain innovation can be framework increasingly transparent to distributing the database record cliently. So it be entire framework exposure. It can be centralized. If the system can be hacked, it probably influence of the particular whole framework. So what are the issues and challenges we are facing into the blockchain? Mostly provide the user features, store all information. Can be
Sorry to interrupt you, ma'am, but you have last 1 minute.
Okay, sorry. So it will be used immutable, and the what is the issues like it is kind reliable, robust, and load balance storage system to allocate based on the individual performance. So currently, blockchain, compelling the making sure of the system dealing with the information, so can be it will be neglect to scare after the age of the record system size. So it's in some little expense and blockchain it is kind of expensive to require motivation kind of miners to giving the convey the record. So giving the strategies to any blockchain specific internet administrations, it can be give the so many frameworks and expected to be encouraged and check off the any earlier agreements be to execution. Unfortunately, the current smart contracts that don't utilize the maximum capacity. So if it is a smart contract we are using, you have to understood about the programming called solidity programming, and then gives the full assemblies to assessment framework. So type of blockchain is kind of, we have the public blockchain and private blockchain and the concept of blockchain. So different application is a kind of, we can use a Bitcoin also, and Bitcoin is a Bitcoin, Ethereum and Hyperledger. So from the conclusion, it can say that from hypothetical, we can see the blockchain is a high worth and great probability of resolving data authentication. So mostly now we can see every sectors we are using the like finance, financially, government and healthcare and auditing firms. People are using the blockchain more as per know, but many people also they didn't know about kind of how to use of this blockchain framework and the Bitcoin and any kind of transparency which are very secure through the blockchain. Thank you.
Thank you, Priyanka. So, likewise, I don't think we have any question. Harsh?
No, sir, there's no question.
Okay. So, Priyanka, have you studied any of the blockchain algorithm or can say process to understand the implementation of the blockchain in various segments like banking, medical?
So right now, actually, I'm working on the blockchain e-governance platform. So in e-governance platforms, most of the like algorithm is there, like like SHA-3 algorithm is there for, and SHA-1 is like algorithm is there, and RSA is there, but it is not mostly RSA is not applicable to my research and in e-governance platform. So right now I'm just inventing whether which will be very more secure for the particular e-governance platform, sir.
Okay, so
So
you are
right
the research scholar.
Yeah, I'm a research scholar, and I'm working on the e-governance platform using smart contracts and solidity, sir, on digital signatures.
Smart contract. Okay.
Yes, sir.
So this is your first paper, means you are doing your research or you are near to submission?
No. I am in like I'm in just
your
completed.
PhD especially.
Yeah, I'm completing first year, sir.
Okay. Okay, Priyanka. Thank you. All the best. Good luck.
Thank you.
Thank you, Priyanka, for your nice presentation.
Thank you, sir.
Okay, so in the end, ma'am, can you please stop sharing?
Yeah, sure. Yeah, thank you.
Okay, so conclude this session. I sincerely thank our session, all the authors for their excellent presentation and their great contribution in this session, and for all the participants for being a part of this international conference. I hope this session was informative enough to all the participants. And further, we on all behalf of our whole team, we are thankful to you to support during this version and the previous 6 version of this conference. And we will be happy to have you all in the previous in the 8th version of this conference in 2024. Moreover, all the participants will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the speaker, and the publication will be live within 5 to 6 months. So kindly cooperate with Team SmartCom 2023. Now, I would like to thank our session chair to chairing the session. And so there is one token of appreciation from the team SmartCom 2022-23 and the Global Knowledge Research Foundation to the chair on behalf of them.
Thank you, Harsh. Thank you for the appreciation, and I would like to pay my sincere thanks to entire team of GR Foundation as well as the team who is organizing the SmartCon 2023. And I'm lucky enough to have this insightful session as a chair, and I found so many good information, and I would like to pay my sincere wishes to all the participants for their contribution. Thank you very much, everyone, and all the best from our side. So you do more research on these areas on which you are working. Good day. Thank you very much.
Thank you, sir. Thank you. Now, in the end, I would like to request you all to turn on your camera so we can capture the good memories of this virtual conference. Just a moment. Just a moment, sir. Thank you all.
Thank you.
Thank you, sir, once again.
Thank you, Harsh. See you on the next version of that. Thank you very much.
All the participants, stay safe and take care.
Thank you.